Hello, Bianca, Desiree, Shanika, Victoria, Ruth, Kristen, Nancy, Diane, Natalie, Yvette, Nicole, Brandy, Lisa, Karen, and Joe. I just wanted to take a minute to go through one of these network diagrams just to give you a little bit more information. I know that some of you had some questions about this, had some issues with it, so I just wanted to give you one more example, and hopefully this will help you to see the value of this. A network diagram is a way of framing a project so that we know which tasks are dependent on other tasks, so which tasks need to be completed before others are completed, and so that we know what is the shortest amount of time that we can complete the project. So in other words, we put together the set of tasks that would take the longest amount of time, and then that is the shortest amount of time that the entire project can be completed. And I know that that sounds kind of counterintuitive, but let me walk through this and hopefully it will be clear by the end. So if we start off here with task A. Task A takes 2 days. So if task A takes 2 days, if the early start is 0, so we always assume that the first task starts on day 0, and it takes 2 days, then the early finish is 2. So and then we move on from there to the next task. Now task C and task B are both dependent upon task A. So the early start for B is 2 based on that early finish day for A. And again, the early start day for C is 2 based on the early finish day for A. And then we just go on from there. So for B, the early start is over here at 2. The duration for task B is 7. 2 plus 7 is 9, so the early finish for B is 9. And again, there are 2 tasks that are dependent upon B, task E and task D. So the early start day for E is 9. The early start day for D is 9. And again, we figure out what the early finish day for those 2 tasks are based on the duration. So the early start day is 9. For E, the early finish day will be 21 because the duration is 12. 9 plus 12 is 21. Again, for D, the early start day is 9. The duration is 6. 9 plus 6 is 15, so the early finish day for D is 15. Continuing on, early finish for E is 21, so we carry that on. That's the early start day for G. Duration for G is 2, and so the early finish day for G is 23. 21 plus 2 is 23. Again, we carry that on, that early finish from G, since I is dependent on it. And again, and here's one of the things. Let me just step back a second here. So the early finish day for D is 15. We see that. So the early start day for H is 15. The duration there is 5. And so the early finish day for H is 20. And now here we have task I is dependent upon 2 tasks. You see that. Task I is dependent upon G, and task I is also dependent upon H. So when you have a task that is dependent upon 2 predecessors, you take the later early finish date and use that, because you cannot start task I until both G and H are finished. So G finishes on day 23, H finishes on day 20, so I cannot start until day 23 because both H and G need to be done. And since G won't be done until day 23, even though H will be finished on day 20, you have to use that 23 day for the early start for task I. And again, the duration for task I is 10, so the early finish there is 33. And if we finish up in the other path on top here, task C starts on day 2. The duration is 5, so the early finish is 7. We carry that early finish over to F for the early start for F is 7. The duration is 12. 12 plus 7 is 19. And again, for here, for task J, we have a task that is dependent upon 2 other tasks. It is dependent upon the finish for I, and it is also dependent on the finish of F. So F finishes on day 19. However, I finishes on day 33. So task J cannot begin until day 33 when I finishes. So the early start for J is 33, the duration is 2, and the early finish is 35. So now we do the backward pass. How can we do the backward pass? Well, the late finish for the end task is the same as the early finish. So we had the early finish here at 35, and so we just bring that 35 down here to the late finish. Then to find the late start, you subtract the duration from the late finish. 35 minus 2 is 33. So 33 is the late start for task J, the last task in the sequence for the project. To calculate the slack, you subtract the late start, you subtract the early start from the late start. So it's the late start minus the early start, and the number you have there is 0. There's no slack in that last task of the project. So working the backward pass, we find that 33 is the late start for task J. And so then we go backward, and that becomes the late finish for task I. It also becomes the late finish for task F. So late finish of F, late finish of I, that's the latest day that those 2 tasks had finished for task J to start for its late finish. And again, in both these tasks, task I and F, it's simple subtraction to figure out what the late start is. You take the late finish right here, the late finish of 33, you subtract the 12, the duration, and then you get 21, the late start. And again, to figure out the slack, it is the late start minus the early start, 21 minus 7 in task F, 14 is the slack. So the slack is the amount of time between the early start and the late start. So you have that amount. So even if you start on day 21, if you start on the day of the late start, you're not going to delay the completion of the project. You're not going to mess up the schedule. That's what that means. The early start is the earliest time you could finish it. The early start is the earliest time you can start it. The late start is the latest time that you could start it, and for the project to still finish on time. Now, I'm not gonna go back through the rest of them. I think that you get the idea I hope you get the idea. Maybe I'll just do a couple more here. In task I, we brought back that 33 right there from task J. So the late start for task J becomes the late finish for task I. We subtract the duration, 10 days, and then we get 23 as the late start. And you can see how it just progresses backward through the pass. I hope that that is helpful. If you have any questions, please reach out to me, get in touch with me. This is not, it's not intuitive, but networks can be really helpful because they can help you see what the dependencies are in a project and where the places are where you can, where if you have a delay, it's really going to impact the finish date of the project. There are some places where you have slack. If you take a little bit more time, you won't have an issue. For example, in task F, so you get done with task C on day 7, and you start on day 7 for task F, and it's going to take 12 days. But you know what? Actually, it takes 14 days. That's not going to be an issue. That's not going to delay the project, because even if your finish date is more, like I said, so if it's 15 days, so it's 24, so your finish is 24, that's okay. It's not going to impact the start of project of task J, because task J can't start until day 33. So if task F finishes on day 24, not a big problem. You have slack in task F. You have some space to take a little bit longer. But any task that's on the critical path, the path of A, B, E, G, I, J, you notice all of those slack numbers are 0. There's no slack there. So if any of those tasks take longer than the set duration, the end of the project will be delayed. That's the definition of the critical path. Again, I hope that's helpful, and if you have any questions, please reach out to me. Thanks.